I'm going to simulate a PC100 input signal with a decade box here. I've also got a multimeter showing the state of relay 1, the limit alarm value. Here is output 2, the relay output 2, the fleeting alarm, and up here a milliammeter showing the retransmission value from the TB45 of the process variable. So if we go back and have a look at TB45, down here you can see the limit alarm value. I've set it at 200 degrees C. Above it we've got the process variable, which I control with my decade box. I've set the fleeting alarm output 2 at 150 degrees C. So if I increase the temperature to 150 degrees C, and if we come back out and look at these multimeters, you will see that this relay, when I get to 150 degrees C, just getting there now, it changes over. If I then continue on past 200 degrees C, we'll now see that this multimeter will change over from close contact to infinite resistance. Looking back now at TB45, you'll notice that the indication light has gone from green to red. If I come back down below 200 degrees C, the indication light has gone to green, so the process is in normal operating conditions again. But here you can just see E. That stands for exceed. LC1, the limit alarm contact, is still latched. If we come and have a look at these multimeters here, you'll see I'm below 200 degrees C, but it's still latched. If I bring the temperature down below 150 degrees C, which is the fleeting alarm, that changes over. But the main limit alarm is still latched. Here I've got the changeover switch. It's my digital input. Now if I flick that digital input, I've reset that latched relay. I'll just put this temperature down to 100 degrees C or thereabouts, and you'll see the multimeter here, the milliammeter, that is changing as well. So if I get to 100 degrees C, which is halfway, I should expect to see 12 milliamps, and there we go. So I have on the TB45 I've got 100, and on the milliammeter I've got 12 milliamps.